So we take more example. In some case too, you will have the denominator of the said function to be a difference or sum of two numbers, whereby both may either be rooted, like we have 1 on root 2 minus root 3, or we can also have the situation whereby we can have 2 on root 3 plus 1. Okay, good. We have a situation like this. In this case, what do we do? How do you do it? We call this aspect of work to be able to solve it. You have to do what is called conjugation. So we call it conjugation. Conjugation. So conjugation of set. So on taking the first part, we have gotten 1 on minus root 3. Now, to work out this, you multiply the top and down by the denominator. But this time, the sign, the operation sign here will change. If it is positive, it tends to become negative. If it is negative, it tends to become positive. So in case like this, we are going to multiply through by root 2 plus root 3 on root 2 plus root 3. The brain behind is to make the denominator perfect square in such a manner that we won't have anything rooted at the denominator. So my next point is continuation. We are going to get root of 2 plus root 3. Then the denominator, if you are weak, you just do it one by one. We are going to have root 2 minus root 3. Then we got root 2 plus root 3. Good. So in expansion, I'm going to get root 2 plus root 3 to divide it. Root 2 times root 2 will give me root 2 squared. If you want to do it in a simple manner, I'm just going to do it in a manner whereby you can easily apply it. So this root 2 is going to multiply root 2 plus root 3. So I'll just take root 2 out. Root 2 plus root 3 plus root 3 out, root 2 plus root 3. Good. So you see how I'm doing it, like we are doing normal expansion when we were doing algebra. So first part, root 2 times root 2 is the figures under the root are the same. So I'm going to get what? Root 2 squared. But before that, remember, you don't get confused. So I just take my numerator along. So I have got my root 2 plus root 3 all divided by. Now root 2 times root 2 is going to give me root 2 squared. Then plus root 2 times root 3. We say if the figures under the root are not the same, you multiply them under the root. So I'm going to get 2 times 3, which is going to give me root 6. Good. Then the operation sign must be negative. Yeah. I'm still maintaining this place must be negative so that it won't create a problem because it's negative here. This is multiplying this and that. And the negative 3 is also multiplying this and that. So I now bring root 3, negative root 3 times root 2, which is going to give me negative root 6. In a sense that, look at it here, negative 3 and 2, that is 2. They will multiply another root, but one is negative, one is positive, so the negative will remain, so it becomes negative root 6. Then negative root 3 squared. Good. Now this is negative, it will clear the positive. The power will blow the root sign, the power will also blow the root sign. What are we going to have? We have the top, which is the numerator, root 2 plus root 3, all on, checking the denominator, we have 2 minus 3. So when you have got 2 minus 3, take 2 from 3 from 2, you'll be left with root 2 plus root 3 all on neg 1. The final answer now becomes negative into bracket root 2 plus root 3. Why do I bring the negative out? This negative is affecting root 2 and the same time affecting root 3. So you bring it out. It's the same as bringing negative 1. That is a negative. So this will become the solution to the first question.